Okay, so we're going to take a look at systems of inequalities. So I'll do a quick review over graphing inequalities themselves. And the good news is, if you're already comfortable with graphing a inequality, a linear inequality, then graphing a system of inequalities is like basically you just do that step twice or 3 times or however many inequalities are in your problem. So it's not overly complicated. If you have forgotten how to graph inequalities, then I'm going to go over that. We're going to take a look at it. But then as far as the system part where we put a few of them together, it's actually pretty straightforward. So let's kind of have a quick review here to remember some of the earlier topics. So we can graph a line, right? So here's a line, 2x plus 3y equals 6. When we graph the equation of that line, then the points on this line are the solutions to that equation. So I can grab any point on this line, take that x and y value, plug it into my equation right here, and it will give us a true statement, right? It will work out. So what we're looking at when we graph a line is a visual representation of the solutions to this equation. Okay, so we've been doing that since beginning algebra. So what happens then when we bump this up to an inequality? All of a sudden we get something like this. So now I've taken 2x plus 3y equals 6 and I've turned it into 2x plus 3y is greater than or equal to 6. So what happens is we still get that same line that we got before, right? In fact, we can see that the line is the boundary between a shaded region and a non-shaded region. So let's remember what that means. So this line is still part of our solutions because for the same reason as a minute ago, if I take any points on this line and I plug the x, y values in here, we will get equality, which is true in this statement. It gives us a true statement. But also we get this whole other shaded region. It turns out these are all solutions over here. So anything on this side of the line, if we just randomly pick a point on this side of the shaded side of the line, we will also get a solution. So when you graph an inequality, one of the sides of your boundary line is going to be all solutions, and the other side won't have any solutions at all. So what you have to figure out is where this boundary line exists. And the good news is that just comes down to graphing the equation of the line, which is one of the first things we learned in algebra. So you can use a table to do that. Remember, you can pick x values, figure out the corresponding y values, and graph the line that way. You can graph it using the slope and the intercept. That's perfectly fine. We've learned a whole bunch of different ways before this for how to graph lines, right? So basically, that's your goal number one when you're looking at this inequality, is you just temporarily treat it like an equation of a line, and you graph that thing. Then you have to figure out which side you're going to shade. Is it this side down here or this side up here? Now, we already saw the answer because I just showed you, so we already know it's this side up here, but how would we figure that out? What you do is you randomly take a point from over here and you plug it into your inequality. So let's just randomly take a point from this side over here. Why don't we take the point 3, 5? Okay, so here's my point 3.5. I'm kind of in the way of it a little bit when I'm trying to show the graph. Oh, it looks like we can make this work. But anyways, you can see what's going on. I'm graphing a test point 3.5, so a randomly selected point on this side of the line. The x value is 3, the y value is 5. And notice when I plug those values in over here, well, 2 times 3 is 6, plus 3 times 5 is 15. So 6 plus 15 is 21, and that is, in fact, greater than 6. So what that tells us is this point right here is a solution to the inequality that we have right here. In other words, that's telling us to shade this whole side of the line where our test point came from. So we don't actually graph the test point. We just kind of know which side it came from, and then we shade that side of the line, and it looks like this. So the reason we do this is there's no real good notation for describing the shapes that we get when we solve these inequalities. So really the best way to represent those solutions is by graphing them. So that's what we do. Okay, so that's your quick reminder of how to graph inequalities. What we do with the system of inequalities, it's the same idea as for a system of equations, right? When we have a system of equations, we want to find solutions that satisfy all the equations in our system. When we have a system of inequalities, we want to find the region that holds the solutions that satisfies all of the inequalities in our system. So basically what we're going to do is we're just going to do this step that we just did. We're going to do that repeatedly until we can figure out the region that we care about. So let's say that I had the system 2x plus 3y is greater than or equal to 6, and y is less than or equal to 2x minus 1. How am I going to figure out the region that I'm supposed to shade there? Well, we take it one at a time. So first I figure out, using the techniques I just talked about, we figure out that this is the part that satisfies our first inequality. 2x plus 3y is greater than or equal to 6. Then this is the region that satisfies the second inequality. Y is less than or equal to 2x minus 1. So we get that using the same process that we just did a minute ago. And now look at when I look at the two together. What do we have? We have 4 regions here. You can see that this has divided our region into 4 sections. Over here, this isn't shaded at all, so that doesn't satisfy any of the inequalities. This over here is orange, so it just satisfies, this region is the solutions that satisfy the first inequality. Down here, we're just blue, so that's the region that just satisfies the second inequality. And if you look over here, it's been shaded both times. So this is actually the area we want to shade. This is actually representing our solutions. So in real life, we don't want to have 4 different versions of shading. We just actually want it to look like this. This is what it should look like when we're done. We've got our boundary lines. This is the region being shaded over here. And that's what our final answer should look like. So on the homework, there's a variety of different problems you're going to do. One of them is you have to get used with the new graphing tool. So it's going to have you graph a line, and then it's going to have you grab this little tool to color it. And it looks like a paint can, little can with paint in it that's like spilling a little bit. So what you'll do is you'll just grab that, and then you click the part of the graph that you want shaded, and it's going to fill in that shading for you.